On this episode of the Water Table Podcast, we're talking pipe perforations and sock fabrics. What is best for your soils and your farm? Well, welcome back to the Water Table Podcast. This fall, I've had kind of a break from doing some podcasts as we recorded several of them at the Iowa Leica summer field days and had some great guests there. Gotten a lot of good feedback about what we did there, but it's fun to be back in the studio and talking all things water management here on the agricultural side. And today I have Trey Ellis with us. Trey is application engineer for Prinsco, focusing a lot on the agricultural side of our business. And Trey and I want to talk a little bit about size opening of perforated pipe, the agricultural pipe, and what's happening in our farm fields and in more sandy soils, things like that. Welcome, Trey, back to the podcast. You've been a frequent guest and hosted several times also, so thanks for joining me today.
Yeah, I get to do it a little bit different this time here virtually, but always good to be on the podcast and get to touch base with you too.
Yeah, so Trey, you farm a little bit with your dad on the side, work with Prinsco. Maybe in the last 60 days, it's been more like working with Prinsco on the side and farming with your dad. But how was your fall season? Safe, and you have a good harvest?
Yeah, good thing we had about 3 extra weeks of pretty good weather later on after a little bit of snow came through, I think at the end of October. But yeah, everything ended up pretty good, and yeah, got all the work done, got all the tillage done, finally put everything to bed here this last weekend. So another safe, successful harvest, and yeah, good time out in the field. It was fun splitting duties between Prinsco and work, and then had drill a couple weekends in there. So there was a whole array of different work to keep a guy busy for the fall.
So Trey, one of the things I wanted to talk about today and get you on is you've been pretty close to the agricultural side of our business and the technical side of agricultural drainage and agricultural water management. And recently we've seen some advertising and some explanations from some of the companies that make the filter sock fabric around why use sock, when to use sock, that has how do I want to say this? They've monitored some studies that have been out there. They've suggested that we look into some studies, and I think that this is all good intentions, but that some of this maybe was confusing. At least it was confusing to me, and that's why I wanted to bring it up around when we should use a sock filter and when we shouldn't. Let's talk about that a little bit.
Yeah, that's based on fairly recently in the last handful of years, a study out of Michigan State that looked at essentially how easy it is for water to get into a pipe. And they tested all different perforation styles and the use of a sock filter, narrow slot, standard perfs, different perforation patterns, how many per valley, stuff like that. So one of the results that came from that was looking at how easy it is for water to move through that sock filter and into the pipe. And that was one of the conclusions that they got to, is within this small lab scale experiment in pure sand is how they measured all of this stuff. And that's what they found, is that it was a lot easier for the water to get into the pipe through the sock than it was for the other perforation patterns and perforation types. So that's just that scales out to how does that apply on the field, which we've been digging into here especially the last few months of what that actually means for how that affects your spacing or how to use that in different soil types, stuff like that, which we can get into. But that's what kind of all of this revolves around, is a really small part of a equation in say lateral spacing within a big field of how easy it is for that water to get into the pipe. They found sock was the easiest, followed by I guess the most perforated, so say like 8 perforations per valley, followed by say 4 perforations per valley, which is what we do at Prinsco for most of our egg pipe, and then narrow slot and perf too. That's all kind of all within the same similar study that they did. So they split it up between standard perf and narrow slot versus sock.
Yeah, yeah, and for me, I think when I looked at that, and that's really where I wanted to go with this is small scale. You mentioned that very small scale study that was done in all sand, and the variables that are in the field in such a wide geographic area from north central North Dakota is where we sell product, all the way to the Canadian border, and then going south to southern Illinois, southern Indiana. There's just soil types that are it shifts from 100 yards in a field to think that it's going to be the same across 1,000 miles or whatever that is just unrealistic. And so the scale of the study is, I think, what maybe could be, if we're just taking that as that's reality across the entire Midwest and the Corn Belt of the United States, then it probably isn't accurate. And so I just want to talk, have you talk about that a little bit, and then I got a couple more thoughts and questions.
Yeah, and that's what I would agree as well. There is a difference between how do you measure stuff, or how do you, I guess, measure anything within science at a small scale, and then you look at maybe a plot scale, and then you look at field scale, and then maybe like watershed scale. You kind of have to have all of those synced up, and you learn more the more that you scale out this stuff. So this Michigan State study specifically, and they've been doing some other ones in the past as well, some other similar sand taking experiments. Was done very small scale to look at the very minute detail of, like we're talking about perforations, which is really small when you're talking about, say, 40, 50, 60, 80 foot spacing of laterals throughout 160 acres. Really small detail effect, or scaled out when you look at all these equations that they're using in models. I don't want to say it's inaccurate, but there's all sources of error the more that you do scale that out. So this is one of the most thorough studies, and most inclusive for pipe manufacturers, for perforation types. The most broad information that we can get looking at this very niche topic. So which is really cool to dig into these details, but like you mentioned, it is kind of have to take it with a grain of sand, say, looking at lab scale versus how you're planning out your entire drainage system.
Mm-hmm. Mm-hmm. Yeah, and I appreciate you saying that, because the intention of doing this podcast is not to call anyone out or to say results weren't accurate. I would love to see more testing being done on larger scales, and I just appreciate the fact that they're thinking about this and doing these kind of tests to try to find out what the conclusion is. My concern and real reason for this podcast today was just not adding more confusion to where we're at. As I see, we have contractors, and that's really for listeners that are farmers and are wondering about this. Well, what do I do now? We got these studies out there that are showing this, and maybe I'm hearing Jamie say something different. Where I would go with that, my conclusion is, talk to your drainage contractor, talk to the people you trust that are local in your area. They know the soils in your area much better than an industry or a university professional would, several hundred miles away from you, whether it's in your own state or a different state. Those drainage contractors in your area have decades of experience. They know what's going on. They're not going to steer you wrong because they don't want to come back and fix something that isn't working properly either. So if you hear something that doesn't seem right, check it out. Talk to another person. Just like anything else in life, when we hear something that isn't consistent, we should probably ask some more questions. But that's really how I take these studies. It's great we're doing them. It's great to learn more. I think we all in this industry is one of continuous learning, but we also want to take the information we have from those that have a lot of experience and make sure we understand what they think of it too. So,
Yeah, and that's been something that's been kind of interesting for myself is trying to, understand these studies and what they're trying to accomplish, or the questions that they're trying to answer there, and see if that does match up with the contractor of what they think. What have they seen for say performance of using different pipe types and different soil types and stuff like that. So it's maybe not the most scientific on the contractor end of more qualitative data and not necessarily, numbers and percentages, but just more anecdotal of, yeah, no, it seems to work better type thing. And I think you've addressed it on the podcast many times in the past, but, within our whole industry is one of the inherent issues with it is you bury the pipe and nobody knows that it's there. So you don't know what condition it's in or the performance that it has when it's in the ground. It's covered up and you don't see any water sitting on the ground. So, everything must be working fine. And that's also something that has been interesting here, looking at some of the results from this specific study, but then looking at some of the fields that we had pattern tiled, we had them at 70, 80 foot centers, and trying to back calculate what the performance is or what it means within these equations and stuff like that. So we've trying to understand this better. There is still a lot of questions out there for if what we're seeing on both sides is reality, and I think it's somewhere in the middle that everything with a certain perforation type doesn't necessarily drain anything better. And like you mentioned initially, it's a lot of it's based on soil type, so you have to start there and start your design with that in mind, with how that water gets to the pipe first.
Yeah, and sand is not just sand. There's so many different soils within something that might be classified as a certain soil, much finer, much more, clay content, whatever that might be. I'm certainly not an expert, but you just can't paint that with a wide brush. You have to understand what you're dealing with in your particular situation.
Mm-hmm. And I would like to point out too is there was a disclaimer, maybe not a disclaimer, but there's a point that's highlighted within these papers that the reason that you're using a narrow slot or a sand or a narrow slot or sock is when you are dealing with sedimentation issues is sandy soils. That's really the only time that you're going to be seeing much of any of these differences. Where the one of the thresholds out there is 30% clay content. Anything less than that, then that soil likes to move. It's a lot sandier. It's not as cohesive. So that's the stuff that gets into the pipe, settles out, and can plug it up. So when we are talking about performance differences with sock, narrow slot, and perforation patterns, it's kind of cutting that threshold of, you're using sock or narrow slot and sandy stuff, specifically sock, where the performance isn't probably going to be seen in some of those heavier, clayier soils.
Yep. And I think it's a good topic for us to talk about also because, over the last probably decade, narrow slot pipe has just taken over a lot more where there was when there wasn't really the alternative of narrow slot, when manufacturers weren't making very much of it, it was either perforated or sock. Then there wasn't the choice for the farmer or the contractor to think that through and say, is this, if there was a different choice than just those two, is sock the right choice? And that debate just never really happened. It just evolved over the last 10 years, in which there's been more and more narrow slot pipes. So not at all disappointed or concerned that this debate is happening. It's actually a good thing for it to happen because that's just changed very quietly over the last 10 years, where much more narrow slot product going in, and maybe it is the right product. I'm not debating that. But it's what I am debating is that it is a newer product that hasn't been scrutinized that much. So it's good to debate. It's good to think through, and hopefully this podcast today spurs some more conversation around this. If that's what it does, then it's been successful, so that we can help others understand, and maybe we need to learn some things too, and things come out of this like more studies and more conversation. That would be great.
Mm-hmm. Yeah, that's what I just about started with when you first asked the question on when to use what type of pipe, and that's kind of been my answer. I've been getting this question since pretty much since I first started, and I know it existed long before I started with Prinsco here a handful of years ago. But what I've kind of stuck with is if you know you're going to be in a really sandy soil, pure sand, sock is probably the best route to go with something like that. Um, Not just from a performance standpoint, but just from a known filter that you have on your pipe. But if you do start dealing with more variety of soil types, or you're hitting a sand layer, or it's switching from a sandier stuff into more of a silty clay variety or soil type within your field, that's where a narrow slot I think would, you have your insurance of keeping your sediment out, but then also, you're not really restricting your capacity of your laterals or of your performance there when looking at say versus perf and stuff like that. So that's kind of what we stuck with. And then based on a lot of this information that has come out, and it's really great to learn it, I don't think that really sways me from that recommendation either. Of if you know you're going to be in a real sandy soil, probably best to stick with sock. If you want some protection on if you're dealing with a variety of stuff in there, narrow slot has been really useful, and I haven't heard of any or many, if any, systems that are really getting compromised based on using narrow slot.
Sure, sure. I agree. I haven't heard a whole lot about that either. And like we said earlier, if contractors, farmers want it done right the first time, they're paying a lot of money for it. If it isn't done right, they're not gonna just say, oh well, we're gonna just leave that alone. No, they're gonna talk to the contractor, and the contractor is certainly going to talk to the manufacturer at that point. And I think both, whether you're using sock or narrow slot, seem to be working well in the whole industry, not just Prinsco. There could be some opportunities to refine that, and one might perform better than the others. And I think that's what we're talking about. That's what we need to continue to talk about, is what is the best product for a particular application. So good discussion today, Trey. Thanks for joining me. Anything that we need to add to this that we left out?
Just kind of how some of this stuff, when we're talking about performance of your laterals, and I think it's a pretty small difference with the perforation types and stuff that we're seeing. But when you're talking about performance of your laterals and your spacing versus your soil type and all that, is in the broader picture, this also, performance of your laterals affects performance of your main line. And I actually just re-listened to the conversation that you had with Hassan from Michigan State on a previous episode, and he brought it up as well, of if you are having, say, a fairly sandy soil with a high performing drainage system, you have to make sure that your mains are sized properly and sized according to what you have in the ground, not just based on whatever, I like 40-foot spacing. I always use an 8-inch main for 80s and whatever. But this whole system has to work with each other. It's the perforation types, it's the size and slope of your laterals, that size and slope of your main, size of your pump if you're doing a lift station. All this stuff has to work in sync with each other in order for everything to function properly, or to make sure that you're not wasting money by having one limiting factor. Say your main size is too small relative to everything else, so you're wasting money on your laterals, stuff like that.
Yep, and that I think is a place where you start looking at the cost of installing a main. If you're going to go, and maybe this is a little drastic, but from 8-inch to say 15-inch, not only is that costing a few dollars a foot more in product, but it's costing more in installation. But if you're pulling that water off in that 3/8, and it's just totally unrealistic to pull a 3/8 drainage coefficient with an 8-inch main, in that given particular instance, then you're really just spending money that you aren't getting any results from. So yes, it costs more, but maybe you shouldn't do the project at all if you're not willing to pay what you're going to get in performance from the right sized main. So that's what you're saying, and I'm just repeating myself here, but it is true, and it's interesting because it happens so often that it seems logical, but I think when there's a finite amount of money to spend on the farm every year, and when you're looking at it and say, well, I could do 80 acres instead of 40 or 160 instead of 80 if we kind of size this main a little differently. Don't probably think that's the way to look at it, because you have to size it correctly and not by how your budget works.
Mm-hmm. Yeah, and that's I guess just to keep echoing on that point, is design that with not only what you have planned and the acres on it now, but if there is more acres within that watershed, or the neighbor's water has to come your way anyway. The low man always has to deal with the water from the higher stuff drains first. So it behoove you to size your main according to not just what you're doing now, but for what could happen in the future, whether that is splitting laterals or adding on more acres, or different crop rotation or something that you're looking at in the future too. So you mentioned it, that these systems are designed and installed to be in there for a while, more than a generation. So kind of the do it right once mentality can pay off, so then your grandkids aren't yelling at each other on having to upgrade their main since everything's flooding out too.
Yeah, and we've talked here. You've been part of that on the water table about main sizing and about large diameter pipe and installation and all that. But we probably haven't talked enough about it. When you really think about how important that is to the entire system. I guess without me actually saying it, I'm inviting you back, Trey, for a future podcast to talk about that stuff more, as it's just really important, and it's part of the forgotten part. It's not the fun part of doing a system. It's fun to see all those laterals across the field and to know how they're performing, but they're only going to perform as well as what they're draining into, or what they're outletting into. So
yeah, maybe just to tack onto that one more time too, is the material and stuff like there. I know down here around ourselves in southern Minnesota, a lot of old clay and concrete tile that's still there, that's still functioning, still looks good, and that's the outlet for a lot of the stuff that we're continuing to hook onto. Might look good now. That's not to say once you start throwing another 40, another 80 acres on this stuff, that added water going through that old infrastructure, that's going to have consequences in the future too. So, like I said, it's thinking about these systems as they are, what you're doing now and how they're going to be used and how they're going to function in the next 50, 80 years. If you do start hooking on a lot more water onto these already old systems, even though they do look good, they are functioning well for what's on them, that might not be the case here once you get a lot more CFS running through it.
Yeah, and I'm smiling as you're talking about that, because I have some personal real life experience with that, and this last year of random pipe out in the field, and I think it's another opportunity for another podcast around people that are doing drainage systems and putting drainage systems in areas where there isn't existing random tile, have a huge advantage over those that are in areas where there was stuff done 30 years ago, 50 years ago, 80 years ago, whatever it might be, and that's not well marked, or you don't know about it. I didn't realize until this fall how you do find that stuff, but you find it in ways that are not very fun and create a lot more work for the farmer, for the contractor, those kind of things. And if more conversation around those topics and how we can do that better as an industry would be beneficial to everyone. So we should do that.
Agreed. That'd be fun.
All right, Trey, thanks for joining me today. Let's keep this conversation going. It's great for people to for the water table to be a place for people to come to and when they have questions and concerns about different things. So happy we could do that today on perforations. So thank you very much.
Yep. Thanks again for having me.
Well, thanks for listening to this episode. I have so much fun recording these. I hope you have as much fun listening as I do recording. These episodes are available on all major podcast platforms as well as YouTube. So find them and download them when you can. Thanks for joining us.